Hello students, in the previous video we discussed about the properties of the charges. Now we will discuss about the methods of charging. Charging, what does it mean? Whenever a substance has got an excess of electrons or a deficit of electrons. Yesterday only we discussed about the frictional electricity, and we discussed that when the electrons are shifted from body 1 to body 2 or body A to body B, both the bodies get charged. So similarly, charging, that means a body has got the charge. How is it possible? One method we had already discussed, charging by friction. In this method, suitable materials, when rubbed together, they get electrified. Suitable means the two systems, the two bodies must be capable of transferring the charges amongst themselves. They are called as the suitable materials. So when they are rubbed together, they get electrified, means they have an exchange of electrons. The body losing electrons acquire a positive charge, and the body gaining electrons acquire a negative charge. For example, glass rod rubbed over the silk cloth or on the cat's fur. In this condition, they both get charged. The other method is charging by conduction, which is a very common method in which an uncharged body is placed in contact with a charged body, and what happens that in this process the charge from charged body shifts itself towards the uncharged body, means a kind of redistribution of charges take place. So the charge divides itself equally on both the bodies. So the bodies acquire equal and similar charges. Similar means if first body had positive charge, so now both will have the positive charge, and if first had negative charge, they both will have the negative charge. So in this method, in conduction, when the charged body is kept in contact with an uncharged body, the charges will divide equally on both the bodies. Now, in both these methods of conduction and friction, a physical contact between the two bodies is a must. If they are not in contact with each other, then there will be no conduction of charge, or frictional electricity will not be possible, because there also we had to rub the two bodies together. But is it possible to transfer the charge from a body to another body without a physical contact? Recall an activity that you might would have done in your childhood. You must would have rubbed a comb or a plastic scale on your dry scalp, and might would have put it in contact with some bits of paper, and you would have seen the papers getting attracted towards that comb or that plastic scale. Isn't it amazing? At that time it was a game for you, now it's a method of study. That is possible only because of charging by induction. Yes, charging by induction. This is the phenomenon in which a temporary electrification of a conductor takes place when we keep a body in contact or in a neighborhood of a charged body. Not in contact, but in the neighborhood of a charged body. So the closer end of the charged body provides an opposite charge to the nearer end of the uncharged body and similar charge to the farther end. That is, opposite charge appear at the closer end and similar charge appear at its farther end in presence of a nearby charged body. This is what is induction. In short, we can say development of charge on an uncharged body without having a physical contact, direct physical contact with a charged body. In conduction, we had understood that the charges distributed will be equal or similar, but here the charge will not be similar. If we bring a positively charged body, the induced charge will be negative, and if we bring a negative charged body, the induced charge will be positive on the closer end, and a similar charge on the farther end. This is the phenomenon of induction. Now in this induction, we will discuss here charging of a sphere by induction and charging of two spheres by induction. These two activities, these two processes we will discuss here. Charging of a sphere by induction. This will make it more clear what actually induction does. We take an uncharged body on an insulating stand. Insulating stand means this will not provide any contact of that conductor to the earth. We bring a charged rod with a negative charge on it in close neighborhood of this uncharged body. The negative charge on the rod pushes the electrons to the farther end. We know that the substance, the conductor, will have some free electrons. So those free electrons are pulled away from the closer end and they get collected over this side. So automatically the surface closer to this body acquires a positive charge. The concept: opposite charges appear at the closer end and similar charge at the farther end. Opposite charge at the closer end, similar charge at the farther end. Now further, we just use a conducting wire to connect this farther end to the ground. This is called earthing. Earthing means when a charged body is connected to the earth. What happens? The positive charge is bound to this negative charge of the rod, but this negative charge, being free on this surface, gets earthed. It flows down to the ground and this surface becomes uncharged. If we remove this conducting wire now, so this is a formation that the nearer end is having the bound positive charge, bound which cannot flow away. Why it is bound? It is bound because of the presence of this negatively charged body. We discussed the fundamental law of electrostatics. Like charges repel and unlike charges attract. So these unlike charges are attracting each other, so they are held at their positions. The next step, what we do, we just take away this charged body and this positive charge of the surface spreads uniformly on the sphere. This is how we can charge a sphere by using the phenomenon of induction. Remember, if we have to make it a positively charged body, we will bring a negatively charged rod, and if we have to make it a negatively charged body, so definitely we will bring a positively charged rod. Now further, if two spheres together simultaneously, they are to be conducted or they are to be charged. So we keep these two spheres A and B in contact with each other, kept on the insulating stands. Now say this time we bring a positively charged rod close to the surface of A. We will not connect it, we will just keep it in the neighborhood of A. What happens? Because it is positively charged, so it pulls the electrons towards itself. So the nearer end of A, the left end of A, acquires a negative charge and the positive charge is pulled or pushed towards the right side of the sphere B. Here the negative charge is accumulating, but it does not cause that the entire electron should shift to this surface. Why it is so? As soon as the electrons start collecting on the left side of A, they further oppose or repel the inflow of electrons. Like charges repel each other, so it means these electrons will further oppose the inflow of more electrons. In this process, some charge is developed on this side negative and this side positive. Now what we do? Slightly separate body A and body B, very slightly. Means just the contact between A and B should be broken. Now the A is having a bound negative charge and B is having a positive charge. As soon as we put off this rod, the charge on A shifts to the right side and charge on B shifts to the left side. This is negative this is positive, so they start attracting each other. But this cannot go out because A and B is having air in between them, and this is a kind of poor conductor of electricity, or we can sometimes also call it as the insulator. So A is having a negative charge on its surface, right surface, B is having a positive charge. As soon as we separate them further, body A and body B are separated away from each other, the charge on A spreads uniformly. Similarly, the charge on B spreads uniformly. So A acquires a negative charge and B acquires a positive charge. Now what happened? If it would have been a negatively charged rod, so what would have been the charges? Yes, right. A would have acquired a positive charge and B would have acquired a negative charge. So this is how we can charge a single sphere or two spheres together by the process of induction. This is all about the induction. Thank you.